There's sunset at Lake Ballinger. And so I'm out here in the middle of Lake Ballinger in my kayak. My pre-calc classes are learning about waves, and so thought I'd do a bit of a field trip here. Wow, geese and stuff flying over my head. Hope they don't poop on me. So anyway, I wanted to give you guys an opportunity here to join in the field trip, even though I don't know anything about waves. So I'm thinking about you guys and have a great time learning about substitution here in just a jiffy.
Well, good morning, algebra. Here's the do now for today. We're going to go ahead and evaluate these two functions. For part A, we're going to do f of 2 and f of 4. So those are the inputs. There's your function, negative a half x plus 2. For part B, evaluate g of 2 and g of 4. So those are your inputs again. And function g of x is 2x minus 8. All right, I'll hang out here while you work out those evaluations. All right, hey, so for A, we're going to drop 2 as the input into that function. We come out with an output of 1. And when we use 4 as the input, negative a half times 4 is negative 2 plus 2 is 0, so our output is 0. For part B, same inputs. We're going to use 2 as the input of this function. 2 times 2 is 4, minus 8 is negative 4. And as last input here, negative 4, 2 times 4 is 8, minus 8 is 0, so our output is 0. I dropped those inputs and outputs into a table. It's not required, just as a way to show some organization here. So on the left-hand side there, you got f of x, input of 2, output of 1, input of 4, output of 0. And for g of x, input of 2, output of negative 4, input of 4, output of 0. Well, today we are looking at substitution, solving systems of equations using substitution. And systems of equations, learn how to solve these means to take two equations, deal with them together as a system. Altogether, there's 3 methods we will learn to solve a system of equations, and substitution is method number 2. So our learning target, you'll be able to solve a system of equations using substitution. It's hiding. All right, well, so just to recap, here's what we saw in the do now. We had these 2 different equations. F of x is negative a half x plus 2, and the second one there, g of x equals 2x minus 8. And what we found was, in the do now, was that if we had an input of 4, and use that in the function f, input of 4, we got an output of 0. And in function g, if we use an input of 4, we got an output of 0. That's the same coordinates. We got 4, 0 for f of x. We got 4, 0 for g of x. Same input, same output for both functions. If I was to graph those 2 lines, negative a half x plus 2, y-intercept 2, slope of negative 2, that's the green line, and g of x, y-intercept of negative 8, slope of 2, it gives me this red line. I could see on the graph that those 2 lines cross at the point 4, 0. That is the solution. And the coordinates 4, 0, that's the same point on the green line and the same point on the red line. That is, in fact, a point which exists on both lines. It's the same point, both lines. And so you notice same showing up a lot here. When we see 2 lines and we graph them, the solution of a system is where those 2 lines exist at the same point, or where the lines cross. We can see that. And if we are looking at some other display, like a table, the coordinates that make both equations equal the same thing. That is the solution. Same, 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 same. Okay, that idea of sameness is the key, foundational, fundamental, most important thing that we need to focus on when we're solving systems of equations. And so that gives us some options here. One thing we can do, if we have 2 quantities that are the same as each other, whether they look like they're the same or not, we know that they are in fact equal to one another, we can substitute them. So I can say, look, I got a number here in an equation or something. I can take that out and replace it with this other thing, which I know is the same. It's not going to change the meaning of that equation. I take one thing out, I put in another thing that is the same, you get the same answer. Okay, so that is the basis of substitution. We got some steps here. Step 1, you have two equations, right? Pick one. Solve either of the two equations in the system to get one variable by itself. So that means either x equals form or y equals form. Typically, we go with y. There's no reason you couldn't use x equals. Step 2, substitute that expression into the other equation. We'll see what that looks like in just a jiffy. And then step 3, solve for the one remaining variable. Step 4 is our final step. We need to get both the x and the y coordinates. So once we've solved for the first variable, we need to use that, put it back into either of the original equations, and then find the other variable. So here's a system of equations. Let's use this as an example. I got a green equation, y equals 4x minus 3. A blue equation, y equals negative x plus 7. Both of these equations have already been solved for y equals. So that's step 1 in our process, get one of the variables by itself. That's already been done for us. And then step 2, we're going to make the substitution. So I'm going to use this opportunity as a pop quiz. What does the equal sign mean? Equal sign, you're right. Equal sign means same. For example, if you had 2 plus 3 equals 5, I know a lot of times we think, oh, the equal sign means that's where you find the answer. And that's kind of a way of thinking it, but that's really not what it means. It means you got 2 plus 3 over here. That is the same as the 5 on the other side. The two sides of the equal sign are the same. They look different because it says 2 and this plus 3, and that one says 5, but they're worth the same amount. This is where substitution comes in. I'm going to use soccer to make an analogy here. I know lots of sports have substitution, and soccer is the only one where at the professional level you get this awesome symbol that works for our analogy. The assistant referee over on the sideline will hold up the substitution board with the number of the player going off and the number of the player going on. And so we're going to make an assumption and say that if we're making a substitution, we want to take we're going to make a like for like substitution. We got a forward coming off. I'm going to put another forward in. And obviously in real life, that's not always true. Sometimes you get to put a player in a different position, change formations or tactics or whatever, but it will just simplify this. So I'm going to take a forward off. I'm going to put someone back into the place, the same position. So if y is coming off and 4x minus 3 is going on, they do the same job. They have the same position. They are the same. I'm going to take one off. I'm going to put the other one on. Play on. Okay, so in the system of equations, I have two equations. This top one, we're going to say this is like the coach's roster, where I got y is equal to 4x minus 3. That means they both do the same job. They have the same position. Okay. So the second equation, this blue one, we can think of that like that's the soccer field, and there's y out there, doing her job on the soccer field. And so we're going to make this substitution. That means I'm going to take y out of that blue equation, and in her place, I'm going to put the 4x minus 3. So y is not on the pitch anymore. 4x minus 3 goes into her place. Just going to rewrite that so we don't have scribbles. So 4x minus 3 is negative x plus 7. All right, we're not done. That's substitution. Right? I had originally in that highlighted blue equation, I had a y. I took the y out and I used the expression from that first equation to take the place of y, to substitute instead of y. So an important couple of observations here. Originally, we had two equations. We had a green one and a blue one. There were two equations. Each of those two equations had two variables. Each of them had an x and a y. In this new purple equation I've just created by doing substitution, now I have one equation, and it has only one variable. The only thing in there is an x. It shows up in a couple of different places, but the only letter is an x. And this gives me an opportunity to practice what we learned earlier in the year. We're going to solve this equation. I've got x on both sides of the equal sign. So I am going to drop a line down from that equal sign just as a way to keep my work organized, the graphic organizer, to keep track of that equal sign. Whatever I do on one side of the equation, I got to do the same thing on the other to keep this equation balanced. Okay, I also want to keep track of like terms. So I'm going to have a couple extra columns here. I'm going to keep x's, x terms, I'm going to keep those separate from constants. Like 4x is not the same kind of number as minus 3. Right? If you've got an x on it, that's a different type of number than just the constant negative 3. Okay, so I'm going to keep track of my my columns, so I keep like terms together. And then my first objective in order to solve this for x is I don't want to have x on both sides of the equal sign. I want to bring those together. So I'm going to cancel one of those out by using opposite operations. So I got two choices. I could subtract the 4x. That would cancel this first 4x here. Or I can add 1x, and that will cancel out this other x. I would like to get rid of the negative number. Also, I'd like to work with smaller numbers. So I'm going to do with adding x. I'll have to do the same thing on both sides of the equal sign to keep my equation balanced. Negative x plus another x gives me nothing. Let's work down each column here. So in the first column, 4x plus x, that plus x means 1x, whether there's a 1 written there or not. 4x plus 1x gives me 5x. That minus 3 is going to come straight down to the next line. The equal sign comes down. This third column, there's nothing left. I had a negative x. I added x. It gives me nothing. Sometimes people want to write a 0, which is fine. It equals 0. A lot of times it gets more confusing for people because then you're like, oh, I've got to cancel out the 0. No, you don't have to cancel out a 0. It's nothing. There's nothing. You don't cancel out nothing. So let's just not write anything. And then this positive 7 comes down here at the end. I don't really need that positive sign there. I don't need the plus. I'm not really adding. I mean, there's nothing there to add with the 7. If I just wrote a 7, it would still mean a positive number. So you could leave the plus sign off here if you wanted. Okay, second step, trying to get the x by itself. So I need to cancel the 5 off of there, and I need to cancel this negative 3. If I remember my order of operations for solving, SADMEG, I'm going to deal with subtraction or addition first. And that means I need to add 3 to cancel that 3. I do the same thing on the other side of the equal sign. These are going to cancel. So this 5x comes down. Nothing in the second column. I got my equal sign. Still nothing in that third column. And then 7 plus 3 is 10. Last step, I need to get that 5 off of the x, so I just have x. And so the 5 is attached by multiplication. That means I need to divide. I'm going to write my division using 2 different symbols, just so we remember there's different ways to write division. They all mean the same thing. 5x divided by 5 gives me 1x, or just x, equal sign, and 10 divided by 5 is 2. Yay, so we solved for x. That is not the end, because we're looking for the coordinates, plural, both an x coordinate and a y coordinate that make both equations equal the same thing. When we looked at the graph, our solution had 2 coordinates, an x and a y. When we looked at the tables, our solution had 2 coordinates, an x and a y. So we need to get 2 coordinates. So let's keep going. So we found out that x equals 2. Yeah, that was half of our solution. And we've done almost all of the work, but we only have half of the solution. So we still need to get the y coordinate. So to get the y coordinate, we're going to go back to those steps that we saw earlier. We're going to, at this point, do step number 4. We're going to substitute x equals 2. We're going to substitute that number into either of the original equations to find y. Okay, so we're going to use, I'll just demonstrate both. You could choose either the green equation or the blue equation. It really makes no difference at all. It's your choice. Maybe one of them is easier, maybe not. You're going to get the same answer, so it doesn't matter. Just pick one. So if I do the green one, equals 4. I'm going to fill that 2 in just a second. If I were to do the blue one, it would look like this. Y equals negative. And again, I'm going to fill that parentheses in where the x used to be. I'll fill that in just a second. Okay, so if I put a 2, 2. Okay, let's just look at one at a time. So if I were to do the green one, 4 times 2 is 8. 8 minus 3 is 5. So y is 5. Look at the blue one. So negative 2 plus 7. Negative 2 plus 7 is 5. Either way, I'm going to get the same answer for y. Now I know x is 2. I knew that from before. And I know that y is 5. So I can write my solution. I need both the x and the y coordinate. Parentheses, separated by, that's a comma right there. There's what substitution looks like. Okay, well, let's try another example. Let's do this one a little bit less explanation. Maybe we can work through this faster. So I got two equations. I got a green one, and I got a blue one. So again, let's say that this green one is like the coach's roster. So I have two players. I got Y. I got the other player, X plus 1. They both play the same position. All right, the blue one, let's say that's like the players out on the field. Y is out there right now. We're going to make a substitution. I'm going to take Y out of the game, and in her place, we're going to put X plus 1. Let's go ahead and rewrite that without the scribbles. So I got X plus 1 equals negative X plus 5. Keep track of my equal sign. Keep track of my like terms. I want to get rid of the negative X. You don't have to. You could do it the other way. But I'd rather get rid of the negative X to start with. So these are going to cancel. In that first column, X plus X is 2X. The positive 1 comes down. Equal sign comes down. The third column, there's nothing there. And in the last column, I got positive 5. I could just say 5. Next, I want to get the X by itself, so I'll need to get rid of the other numbers that are on the same side of that equal sign. Let's subtract the 1. And then 2X is going to come down in that first column. The second column, now there's nothing there. I've canceled that. Still need the equal sign. Third column already had nothing in it. Last column, 5 minus 1, that's 4. And then lastly, I need to divide both sides by 2 so I can get X all by itself. Just a teeny bit more space. Oh, that's too much space. So X equals, and 4 divided by 2 is 2. So here is my X value. Coincidentally is the same as I got last time. It's not always going to equal 2. We just got two problems in a row that happen to have the same X coordinate. Right, so there's half the solution, but most of the work, but only half the solution. So let's take that 2 and put it back into either the green or the blue equation. Of course, either one is going to give us the same answer. Let's do the green one first, and the green one, I just dropped that 2 in there in place of X. 2 plus 1, that's 3. And if I was to use the blue one instead, drop that 2 in there, and that makes negative 2 plus 5, which is 3. So either way, I'm going to get that same y value of 3. So my solution, let's write this down here. X was 2, y is 3. I'm going to write these as coordinates inside parentheses, separated by a comma. There we go. That's how solution works.